Bismillahirrahmanirrahim. Assalamu alaikum, dear student of Divisional Public School, Lahore. Class 9. Today's lecture is about the review exercise of unit number 5. I'm your teacher and my name is Saima. Dear students, now we will move to question number 3, first part of review exercise, in which we have to find the solution region of the system. Here, students, we are given with a set of inequalities, that is 3x minus 4y is less than equal to 12 and 3x plus 2y greater than equal to 3. To find the common region between these two inequalities, the first step is to find the associated equations related to these inequalities. Students, the method of finding associated equation is this, that we will replace simply our inequality sign with the sign of equality. For the associated equation of inequalities 1 and 2, we replace the sign of inequalities with the sign of equality. We will get 3x minus 4y equals to 12, which is L1, is associated equation of the first inequality, and then 3x plus 2y equals to 3, L2, is the associated equation related to the inequality 2. Students, simply we will find the associated equations of inequalities by replacing our sign of inequality with the sign of equality. In the next step, students, we have to find the intercepts for both of the L1 and L2, both of the lines or both of the equations. To find the intercept, students, first we will take the first equation, that is 3x minus 4y equals to 12. Students, we will take this equation 3x minus 4y equals to 12, and first we will put x equals to 0 in it, and we will get the value of y, that is equals to minus 3. Then we will put y equals to 0 and we will get x equals to 4 for this, and we have now 2 points A and B. Students, with the help of these 2 points, we can plot easily a straight line related to L1, 3x minus 4y equals to 12 on our graph. Dear students, after finding the intercepts for the line 1, now we have to repeat the process for the second line. We have to find the intercepts of the second line L2. As you know, the equation for the second line is 3x plus 2y equals to 3. Here I will write it down the equation for you, that is 3x plus 2y equals to 3. Now first we will put x equals to 0 here to get the value of y, and then y equals to 0 to get the value of x. I have now point P and Q for L2. Now I have both of the intercept for both of the lines L1 and L2. Now our next step is to draw our boundary lines. For this, students, first we have to join the point A and B to draw L graph paper. Here you can see, students, that we have plotted both of the equation. You can see that we have first equation is 3x minus 4y equals to 12, and the line which is plotted here is 3x minus 4y equals to 12 is the line showing the point A and B. This line is for the equation 3x minus 4y equals to 12. Now for the second line L2, we have this line. Here we have 3x plus 2y equals to 3. The point P is on y-axis and that point Q is on x-axis. Here you can see that we have x axis here and we have y-axis. So now we can easily plot these two lines on our graph papers. Students, after plotting our L1 and L2 on a graph paper, now we will check the test point. Here the test point is the origin point. As you know, the value of x on our origin is equals to 0 and the value of y on our origin is also equals to 0. Now students, first we will take the first inequality which is given in the question, that is 3x minus 4y is less than equal to 12. We will put x equals to 0 and y equals to 0. After putting this value, we have the statement that 0 is now less than equals to 12. Students, now if this statement is true, then we will shade the side containing the origin. And if that is false, then we will shade the side containing not the origin. So here it is true, so we will shade the part of the graph which will contain the origin. Now we will take the second inequality, which is 3x plus 2y greater than equal to 3. As we have to put origin's point, which is x equals to 0 and y equals to 0, so after that we have a statement that 0 is greater than equal to 3, which is a false statement. So now we have to shade the side not containing the origin upper half plane for L2. Dear students, now we will shade the region that satisfied both of the inequalities. Students, as we know in the previous step, that we done the test point for the first inequality, which is true. So first L1 included that area which includes the origin in it, as I mentioned by the arrows, that L1 have true test point test, so that's why it includes the area in which origins included. For second inequality, as you know that test point is false, so it includes the area in which origin does not include, so this area will be for the second inequality. Students, now the common area for both L1 and L2 is this one. So this one is our required region, shaded region for both of the inequalities. Now students, we will move to the second part of question number 3. Here again another set of linear inequality is given. The first thing is to find the associated equation related to these inequalities by replacing the inequality sign with the sign of equality. Now the associated equations on inequalities 1 and 2 are given. These are 2x plus y equals to 4, x plus 2y equals to 6. Now students, first we have to find the intercept for the line L1, that is 2x plus y equals to 4. When you put x equals to 0, you will get the value of y, and when you put y equals to 0, you get the value of x. Now we have both the points A and B for L. Now students, we have to find the intercepts of the second line L2. We have to label the point P and Q. Now put x equals to 0 in the second equation and we get the y equals to 3, and put y equals to 0 to get the value of x is equals to 6. Now we have the intercepts point for both of the line L1 and L2. Students, now we have to plot these boundary lines. Join A and B to draw the L1, 2x plus y equals to 4, and join P and Q to draw L2, x plus 2y equals to 6. Here I show you the graph. You have to plot it on xy coordinate. Students, here you can see that we will join the point A, B and P with Q. We have two lines L1 and L2 here. For this, next step is to find the test point for both of the inequalities. As I told you before, students, that the test point is the origin point. So we have to put x equals to 0 as well as y equals to 0. First, we will take the first inequality, that is 2x plus y is less than equal to 4. I replace x and y with 0 and I get the statement that is 0 is less than equal to 4, which is true statement. Now students, for the second inequality, x plus 2y is less than equal to 6. Again put 0 for the x and y values equals to 0, which are the values of the origin. So for this, we again have the statement of this inequality, 0 is less than equal to 6, which is true. Now students, as I told you before, that if we have the true statement, then we have to shade the side that containing the origins. And if we have the false statement, then we will shade the side which is not containing the origin. But in this case, both the inequalities are true for the test point, so we have to shade both of the sides which contains the origin for it. Now students, we will move to the graph to find the final shading. Dear students, now we will plot the common area between both of the inequalities. Students, as we done in our previous step, we know that the test point is true for L1. So L1 includes that region in which the origin is included. So for the required region for L1 is this one, this side of the line, and for the other L2 we also have the true test point, so it also included the region which is having origin in it. So the area for L2 is this one. Now you can see that the common area for L1 and L2 is this one. So this one is the common area for both of the inequalities. This is common shaded area between both of inequalities.